All right, today's pretty simple. We're going to talk about rational exponents today. It should be kind of a review of what you've done in the past. If everybody looks behind you to the exponent rules poster back there, it's kind of going to be that stuff. So that'll always be up there if you need to refer to it. I won't cover it up. All right, so the first part here is going from radical form to exponential form. What kind of root is this?
Square.
A square root. So if you notice, since it's a square root, there's going to be a 2 on the bottom of your fraction. And then this is a cube root, so there is a 3 on the bottom of your fraction.
That's all we do?
Well, it gets harder, but so your root is going on the bottom. So the root goes on the bottom. Hi, what's up? Yeah. The way you can remember that is trees have roots, right? And the roots are on the bottom of the tree. All right. This little box here is just kind of generalizing. So if you take the nth root, so any kind of root, and you want to write it as an exponential form, you're going to do 1 over n, with the root still going on the bottom. And what's up? Yeah. And if we have an exponent, if we have an exponent and a root, the way that you would rewrite it is you would put your exponent on top and your root on bottom. So exponent is going to go on top. The root is going to go on bottom. So write that somewhere, box it, circle it, star it. Super important. So when you're going from radical to exponential, exponent over root. All right, so n is the exponent, a is the base. All right, so we're going to fill out this chart here. That's kind of the properties over on the poster. Do you remember, if you are multiplying, what do you do to your exponents? You add them. M plus n. So for example, if you add x to the 5th times x squared, what would your answer be? X to the 7th. Very good. All right, so when you are multiplying, you add your exponents. All right, so if you're multiplying, you add your exponents. What do you think you're going to do if you divide? Subtract them. So I'm going to jump around a little bit, but come over here. If you are dividing, you subtract your exponents. So for example, if you add x to the 5th over x squared, x to the 3rd. All right, so any questions so far? Sweet. All right, so number 2. Number 2, I have an exponent raised to an exponent. Do you know what to do with your exponents then? Multiply, very good. So a m times n. So for example, if you add x to the 5th raised to the 2nd power, x to the 10th. All right, we good so far? All right, number 3. If I have two things being multiplied, and I've got some parentheses, and I have an exponent on the outside. So these parentheses with an exponent. The exponent is going to go to both terms, the a and the b. So it's a raised to the m, b raised to the m. So, for example, if I had 5x squared, you have to square both things on the inside. So you have to square the 5 and the x. So what's 5 squared? 25. And then x squared is just going to stay x squared. All right, that same property is going to work for dividing as well. So if we have two things being divided, the exponent is going to go to both the top and the bottom. So a to the m over b to the m. So if you had 5 over x squared, how would you write your answer? 25 over x squared. Okay, next one. If you have a negative exponent, so if you have a negative exponent, it's going to go to the bottom of your fraction. So going from bottom to top and top to bottom, that's going to change the sign of your exponent. So it's negative, move it to the bottom, it turns positive. For example, if you had x raised to the negative 5, you can move the x to the negative 5 on the bottom, and it will be a positive x to the 5th.
If it was x to the 5th, but it was positive and you moved it, would it be 1 over x to the negative 5th?
Yes.
Okay.
Yep. So moving up and down changes the sign.
Question.
Yes, what's up?
Will we ever be given a problem that's like 3 to the negative 5 over like 2, and then like if you flipped it, would you have to reduce?
Wait, hold on, let me write down what you're saying. Okay. 3 to the negative 5 over 2.
Yeah,
like
like
that?
when you flip that, like you reduce.
So you would flip it, the 2 stays here.
Oh, it does?
Yeah, because the 2 is not negative, so it's just that guy. And so then you just have to multiply all that out. Whatever, 3 times 3 times 3 times 3 times 3. Like 3, 5 times, and then times 2. But probably not. Okay, let's go down here. So on part C, all we're doing is going to rewrite an exponential form. So if you don't want to, you do not have to simplify. So you don't have to simplify on these guys. Because all I want to do is write it with exponents. All right, so that is the goal, which is kind of throwing people. But all I have to do is write it with exponents. So I want to get rid of the root.
So, do you mean like we won't have to simplify it like ever, or just right now?
If the directions say rewrite as an exponential form, I don't care if you simplify it or not. On the back here, when it says writing expression in simplest form, that's when you have to simplify it all the way down using the properties. But if I just say to write it in exponential form, you don't have to simplify it. Okay. You can if you want to. It wouldn't be like that hard, but you don't have to. On number 1, to rewrite it in exponential form, remember it's exponent over root. So on number 1, what is my exponent? A 3. And then what is the root? A 2, a square. And so you would write a and then 3 over 2. Does that make sense? All right, go to number 5.
5 would be 5 over 3, right?
Yep. So 5 over 3. Exponent is a 5, root is a 3, so you rewrite it as 5 over 3. Go to number 6.
The 4 is like the bottom.
2b, 3.
All right, so you have to be careful here because you need to pay attention to what your exponents are. Technically, what is the exponent with the 2?
1/2.
Well, a 1, right? Right now, the exponent with a 1 or with the 2 is a 1. So the 2 has an exponent of a 1. The b has an exponent of a 3. Does that make sense?
So do we have to separate them?
So you separate them, yeah. So you would write 2 to the 1/4, b to the 3/4, because they have different exponents.
I thought, what happens to,
Mm-hmm. All right, so on number 7, how would you write it?
don't you switch much?
No, what's the exponent on number 7?
9,
9, and what's the root?
5.
So you just write 9 over 5.
I thought the parentheses make it switch. So it just shows on 6. Or that's not 6, yeah, 6. In the example, probably.
Oh, you would just, if there was like a fraction here, the 9 would go to the top and the bottom. But since there's only one term here, like, I mean, that term has an exponent of 9. It doesn't matter if it's on the outside or the inside. Okay, on number 8. So number 8, both of these guys have an exponent of a 4, right? So you could distribute the 4 out if you wanted to, or you could just leave it in parentheses with the 4. And then what's my root there?
2.
A 2. So if you wanted to distribute, you could. If you left it like that, I'd be okay with that too. What is 4 divided by 2? So you could also write it like that. Is this making sense? All right. So on number 4, how would you write it? 7 over 4. Good. Okay. Number 3 is going to be a lot like number 6.
So it's going to be like 3, 1, 5.
1 over 5.
Yeah, 3, 1, 5, and y 2, 5.
Yep. So the 3 exponent is a 1. It's understood. That's why it's not there. And then the y has an exponent of a 2. So you would have to split those guys up. All right, now I saved 2 for the last. It's actually, if you just keep it simple, just treat these parentheses as one giant parentheses. Don't worry about what's on the inside because I don't need to simplify. What is the exponent?
6.
What is your root?
3.
So that's all I gotta do. All right, so parentheses is just like, it's like one big thing. So if you wanted to split it up, you could, but that would just be simplifying, and I didn't ask you to do it. So, and then if you wanted to reduce,
It's all about the root.
yeah, you could do that as well. All right, but because the directions only say to write in exponential form, technically that's an exponential form, that's an exponential form. It's just not simplified exponential form. Does that make sense? So, all right. Here we're just going to go backwards. Bye, Ariana. So we have the exponentials. We're going to write it in radical form. So remember, it's going to be the exponent on top, the root on bottom. So on number 9, what's my root going to be?
3.
5.
Yeah.
Oh, yeah. 5.
5, and then what's the exponent? 3. All right, number 10. The root is never negative. All right, the root is never, ever, ever, ever going to be negative. So if you have a negative, it's going with the exponent. Does that make sense? Yep. So 3 is your root. B to the negative 2. Once again, I don't need to simplify. I just want to write it in radical form.
If you technically left the root as negative, could you make it imaginary or no?
No, because so the only way you'll get an imaginary if like your big number is negative.
Okay.
So if it won't make sense to have your root negative. Like it's not like a math thing at all.
Okay.
And so, but with this being negative, that technically means a fraction. So that's why the exponent is negative, because it's that negative property that you'll see later on. All right, on number 11, what's my root? 2. A 2. Do you have to put the 2 there? You don't have to, because if it's not there, it's an understood square root. So you don't have to put the 2 here. If you want to, you could. And then what is my power? 5. Make sure you don't lose your parentheses here, because all of x, y is part of this. You know what I mean? Like parentheses are right here, so they stay right there. All right, can I flip it over? All right. On the back. So, someone want to tell me what this one is? Number 12.
4 square root y exponent 5.
Yeah. 4th root of y to the 5th. All right, so 13. 5th root of AB. Do you have to put the exponent of a 1?
No.
No, because it's understood.
You have to put the parentheses.
No. You don't really even need the parentheses. 14. So square root h, what's the exponent? Negative 3. Good. All right, so are we good going from root to exponential and exponential to root?
Wow.
Sweet.
What happens to the 2? You need the 2.
It's understood if it's not there, because then it's a square root. All right, the last part here is writing our expressions in simplest form. So now we're going to use our properties. All right, so tell me, if I am multiplying, what do I do to my fractions? Add them. Very good. Okay, so I know I want to add 2/5 and 3/10.
7/10.
Yes. All right. To do what Nate just did in his head, you have to have a common denominator, right, before you can add. So we're going to multiply both of these guys by 2 to get 4/10. And so now we can add them and we get 7/10. And so my new exponent is 7/10. All right, 16. Now, look at 16. Do you see how this is an x and this is a y? All right, you can't add up your exponents there because your base is not the same. Does that make sense? Like, if you were to try to do that, we wouldn't even know what to put here because you could put x or y. Like, you can't do it. So you can't add those up, but we do have an exponent on the outside. So what do you do if you have an exponent raised to another exponent? You distribute it, yeah. So we're going to multiply these guys out. So x to the 3/2 times 4, y to the 9/4 times 4. All right, so 3/2 times 4 will simplify to
11/2.
Multiply,
Oh.
which 6. 3 times 4 is 12, divided by 2 is 6. Okay, and then what about these 4s? What happened?
It would be 9, right?
Yeah, they cancel and you're just left with 9. Okay. On 17, what do I do to my exponents? Subtract. So 2/3 minus 8/3 is going to be what? -6/3, which reduces to negative 2. So I have b to the negative 2. And I know that negative exponents are going to be moved to the bottom with the understood 1 on top.
Where did the 1 come from?
It's, you just have to have like a filler spot because there's nothing on top once you move this to the bottom. All right, drop down to number 20. What do you do to your exponents? Add them. 1/2 plus 5 over 2 is what?
3.
6 over 2, which reduces to 3. So your answer is x cubed. And that's all you got to do. You okay so far? You'll have all day tomorrow to practice with the properties. It really just takes practice doing it. On number 19, now you have to really think about what the exponent is. What is the exponent on number 2, or on this number 2? 1. So the 2 has an exponent of a 1. The y has an exponent of a negative 1/3. Does that make sense? Because we're doing stuff to the exponents. We aren't doing anything to the bases. So this 6 is going to multiply by the 1 and the negative 1/3. So we have 2, 1 times 6, and y, negative 1/3 times 6. So you only should be messing with your exponents, like adding and subtracting your exponents and, multiplying them. It's all with the exponents. So think about what exponent there is. So what is 1 times 6?
2.
6. And negative 1/3 times 6? Negative 2. All right. So 2 to the 6 is what? Oh, you probably don't know. I had to look it up earlier too. It's 64. If you had something that big, you'll have a calculator.
Where'd you get that from?
Yeah.
Would it be a negative 64?
No, because like this is a term all on its own.
How do you get that?
The 64?
Yeah.
2 times 2 times 2 times 2 times 2 times 2. 2, 6 times. So, all right, so 2 to the 6 is 64. And I put this fraction bar here because this guy's negative, right? And so then the y2 goes on bottom.
How did it turn positive?
Because I put it on the bottom because it was negative. So when you put it on the bottom, it turns positive. All right. 18. All right, so once again, we're doing stuff to the exponents. So what is the exponent of 27? The 1, right? So we're going to take 2/3. We're going to multiply, multiply, multiply. So I have 27 to the 2/3, x 6 times 2/3, and y 12 times 2/3. All right, so now we're going to simplify. I'm going to worry about this later. What is 6 times 2/3? 4. X to the 4. And 12 times 2/3? 8. All right. So are we good up to that point? This can be my last example if you want.
I'm good.
Okay. The numbers, we can reduce that farther. Is that what you're going to say?
Yeah. What about the 27?
Yeah, we're gonna reduce that. So the 27 we can simplify. The number on the bottom, tell me again, what is the number on the bottom? The root, very good. What is the cube root of 27?
9.
Close. 3. So the cube root of 27 is 3. And so that takes care of my root on the bottom. All right, so everybody see how I got from here to here? So I took the cube root.
Can we just simplify again and do 2/3 of 27, or would that be decimal?
No, yeah, that wouldn't be. Because it's an exponent, so it's It's like weird. You have to do it separately. So take the root and then square it.
So the goal is to keep the exponent, but if we have to, we can get rid of like the root. Essentially.
We're going to get rid of the exponent too. I was just
Oh, okay.
making sure everybody understood how I got here.
The calculator, right?
Probably on some of it, yeah, but you still need to know how to do this with that one. What's 3 squared? 9. So your final answer is 9 x to the 4th y to the 8th. So bottom number is a root, top number is a power. Do you want me to do another one? Are y'all good? What are your thoughts?
Can you do number 23?
Yes, I can. All right, 23. All right, so first of all, let's distribute my -4 into here. So these are both my exponents, right? So I'm going to multiply -4 times that and that. 2, -3 has times -4, and then x, 5 has times -4. All right, so what happens to my 4s? They cancel. What happens to my negatives? They also cancel, right? They turn to a positive. So here I'm just left with 2 cubed. X, okay, 5 has times -4.
That's 20.
Divide by -10, All right, and then I don't like negative exponents, so this guy we're going to move to the bottom. So 2 cubed stays on top. X10 goes on bottom. And then the very last step, what is 2 cubed?
27.
Yep. Sometimes they look really complicated, but once you start simplifying, like it all starts like working out a little bit nicer. Yeah, what's up?
Why is it that when you were working on the exponents, you put the negative number inside? I thought you were supposed to get rid of the negative.
You mean on these guys?
I mean with the radical stuff on the front.
Oh, on the front? These guys?
Yeah.
If you wanted to, I just didn't simplify. So on the front I didn't simplify because it didn't ask me to. If you wanted to simplify this, you could. Is that what you're saying?
Yeah, I was just wondering why there was a negative number.
Yeah. If you wanted to simplify this, you could. It would be 1 over b squared. Does that make sense?
How did you make it get into the radical stuff?
The b -2?
Yeah.
Because the bottom number here is a root, and so it's going to be the cube root, and then the top number is going to be the power, like the exponent. And so,
The power can be.
yes, power can be negative. The root will never be negative. And so then that's why if you have a negative, it's always going to go with the exponent. Does that make sense? Okay. Any other questions?